Hello, today we're going to be working with variables and expressions, and we're going to start out by defining what is an algebraic expression. So an algebraic expression is an expression containing one or more numbers and variables along with one or more arithmetic operations. An algebraic expression is an expression containing one or more numbers and variables along with one or more arithmetic operations. So, what does this look like? We could have the expression 5x. We could have the expression 3y minus 7. There are numerous parts of these algebraic expressions. In this first one, we have two parts. We have this x is called the variable. And this 5 would be the constant. And they'd have the hidden operation there, which is going to be multiplication. Now over here, we have this first term. This first term is going to be called our variable term. This term over here is going to be called our constant term. And we have here in the middle our operation. Now, a couple more definitions for us. A variable. What exactly is a variable? A variable is a symbol used to represent an unspecified number or value. A variable is a symbol used to represent an unspecified number or value. Now we have a variable here which is x. We have what's called our constant. And that is a value that remains unchanged. So our constant does not change. And then over here with this expression we have what's called the variable term or a constant term. So we're going to define that a term is pretty much a lot of things in these algebraic expressions. So a term is a number, variable, or a product, which is the term we use for multiplication, or a quotient, the result of division of numbers or variables. A term is a number, variable, or a product, or a quotient of numbers or variables. So this is all one term, 5x. It has a constant and a variable and a hidden operation, which is multiplication. So we have that product of 5 and x. And then this is one term here, this multiplication of 3 times y, that product. And then this 7 here is another term. It's our constant term. let's get some other terminology out. I've kind of hinted at this, but a product is the result of multiplication. So the product is the result of multiplication, and we call them factors, which is the quantities being multiplied. So products being the result of multiplication, factors being the quantities multiplied. So the way this can look really quickly, there's several ways to write a product. So we could write x times y. We could write xy and hide that multiplication dot. We could write x times the quantity y, the quantity we put in parentheses. We could have the quantity x times y, and we could have the quantity x times the quantity y. All of these are different ways to write multiplication. These are all products, with each of these being factors. These are each products with each part being factors. Now there's one other type of expression that we're going to look at before we get to translating algebraic expressions, and that is a power. So this is an expression written in the form x to the n, which we read x to the nth power. Or, for example, if it was 2 to the 4th, we would say 2 to the 4th power. In these expressions, in a power, when we take x to the n, we have two parts. This x is called the base. That is the base that becomes the factor. When we look at n, which is called the power, not the power, it's to the nth power, but we call n the exponent. Hopefully we've heard this term before. The exponent, which indicates the number of times the base is used as a factor. Now that we've gotten all of that terminology out of the way, let's actually do some examples of what we're here to do. So let's say that our directions say to write a verbal expression for each algebraic expression. We're going to write a verbal expression, so we're going to use words to express each algebraic expression. So let's look at this first example here, and we see. So we see our first example here. We have 3, we have an x, and we have a little raised 4. So we see that we have a bunch of these terms. We're going to go in order from left to right, as you would read. Now, there are a lot of ways that we could say this, and we'll show that now. So we could say 3 times x to the fourth power. We could say the product of 3 and x to the fourth power. The opportunities, we could go on and on for a while, but we'll just give those 2 examples for right now. Let's look at this example. If it says this and for difference, we're going to change this variable to be that. So we have this algebraic expression, and we need to write it as a verbal expression. So one way that we could say it is 5 times y to the second power plus 16. Or we could say the sum of 5 times y, and I'm going to say y squared, which is kind of a bit of a cheater version to say it, but I'll let it slide for now. The sum of 5 times y squared and 16. So we took an algebraic expression and we wrote it as a verbal expression. Go ahead and try this next example on your own. Alright, so we've taken algebraic expressions and written them as verbal expressions. Now let's take verbal expressions and go the other way and put them as algebraic expressions. So we are going to write an algebraic expression for each verbal expression. So if I see that we have a number t more than 6, if we have a number t more than 6, that more than implies that we're going to add them together. So therefore, the algebraic expression for this is going to be 6 plus t, because we're taking t more than 6, or we could write it as t plus 6. Alright, so if we have more than, that's going to be a symbol for addition, and we're going to take 6 plus t or t plus 6. Let's say we have 10 less than the product of 7, not 2, of 7 and f. So I am going to start with the product of 7 and f this time. I'm going to start with the product of 7 and f. If I have 10 less than, this less than implies that I'm going to take 10 away from 7 and f. So I'm going to take 7f minus 10. And also, again, we caught that this product here implied multiplication of 7 and f. So we have 7 times f minus 10. Let's look at one more before you do an example on your own. So C, we're going to look at 2/3 of the volume V. Now, When we call this volume v, that's defining what the variable v stands for. So don't be tricked up that we need to find some volume all of a sudden. No, volume is standing for that variable v. So we have 2/3, which we take as a fraction. We'll say 2/3 of the volume v. This of right here is going to imply that we're going to multiply this fraction 2/3 by our variable v. So we're going to take 2/3 times v. All right? So 2/3 of the volume v, 2/3 times v. All right, go ahead and try an example yourself where you have to write an algebraic expression for a verbal expression. All right, now you've done that, great. Let's take a look at what our assignment is, our practice problems that we have to do before class tomorrow. So our practice problems in our iBook is page 106, examples 11 through 28. What we're going to do when we see that we have practice problems to do is that we are going to label the top of each page. Each page is going to get the top of its own piece of paper, where we're going to write what the assignment is. So page 106, 11 through 28. And we're going to start with number 11. We're going to write the original equation or the original problem that we have to do. We don't need to write the directions. I know what the directions are. So we have to write a verbal expression for each algebraic expression. And number 11 is 4q. So you're going to write 4q as the original problem, and then you'll write what it means, or you're going to do it. So we're going to write a verbal expression. So we'll say the product of 4 and q. And then you're going to put it in a box to indicate that that is your solution, the product of 4 and q. We wrote the original, we boxed our solution. Please skip a line. I had you get big spirals so that you could fit all of this in. It's okay that you skip lines, and then go on to number 12. So number 12 says this. I have you skip lines so that it's okay that this fraction bled outside that line. That's okay. And when we get further along with huge rational expressions, we're going to want to take 2 lines for fractions. So take as much paper as you need, all right? And we'll keep going, all right? Good luck. I'll see you tomorrow.